Okay, so continuing with the solution of the frame problems, the practice frame problems, we're going to do problem number 6. But before we get started on that, I made a mistake on frame problem number 1. On the solution, I wrote that FBE was minus 61.25 pound-feet. It's not pound-feet, it's pounds. So when you go over that, solution, just keep that in mind. If you've already gone over that solution, you probably said, hey, it's not pound-feet, it's pound. Okay, so FBE is minus, for problem number 1, FBE is minus 61.25 pounds, not pound-feet. Okay, so let's turn our attention then to problem number 6. Okay, you look at this, a frame is composed of 3 members, A, B, C, D, and BDE. Okay, pin connections, all of these are pins, A, B, C, D, and E. There's a 4 kilonewton force applied here at C horizontally. There's a 4 kilonewton force here applied at E horizontally as well. Okay, it's supported by a pin at A and a roller at E. All right, so the question is, determine the forces at pin B and in member CD. Okay, now the first thing to do, I think, always, at least consider doing it, is doing a free body diagram equilibrium analysis of the entire frame to get the support reactions, either all of them or some of them. But I see here I have a pin at A and a roller at E, so I have 3 unknowns, AX and AY and EY. So I know by doing equilibrium analysis of the entire frame, I'm going to get all 3 of the unknowns, of the support reactions. Okay, so let me draw a free body diagram of the frame, of the entire frame. Looks something like this. Again, not to scale. All right, that's that. Okay, put my axes on here. X, Y, and X. All right. So here's AY. I'm not going to put the dimensions on here. You have to put the dimensions on, of course, to have a complete free body diagram. I have EY and 4. That's the external load. Okay. And then I have up at C, I have the 4 kilonewton load up here. All right. So there's my entire frame. Again, keep in mind there are forces acting at B, D, and C. All right, the pins. But inside this freed body, all those forces are in equilibrium, so you don't show them. All right. So for the entire frame, 3 unknowns. I have 3 equations of equilibrium, so I know I can get them all. So sigma fx is equal to 0. Tells me ax plus 4 is equal to 0. So ax is minus 8 kilonewtons. Okay. Sigma fy equals 0. I have ay plus ey is equal to 0. I can't get those explicitly from the y equation. So I'll take the moment about either A or E. It makes no difference. Sum the moments around A. Counterclockwise is positive. All right, so that's EY times 400. Look at the diagram to get the dimensions. EY minus 400. All right, going this way. Minus 4, because this 4 kilonewton load at C tends to rotate clockwise, so it's minus 4, and its moment arm is 300. Equals 0. I solve for EY. And EY comes out to be 3 kilonewtons here. All right, and then I have AY plus EY is equal to 0. So AY is equal to minus EY, so AY is equal to minus 3 kilonewtons. Okay. All right, so I have the support reactions, AX, AY, and EY. Okay. Okay, so the question then asks, though, for the forces at pin B, right here, and the force at D, or I'm sorry, in member CD. Okay, so I'm going to take it apart, and I'm going to take a look and say, all right, what can I draw a free body diagram of that's going to answer the questions that are asked? In other words, the reactions are the forces at B and the forces in member CD. All right. And one thing I note is that CD is a two-force member. Okay. Very important to identify two-force members if they exist. So I look at this and I say, well, if I draw a free body diagram of BDE, I already know what EY is. I'm going to only have three unknowns. It's going to be BX, BY, the X and Y components of the force acting at B. All right. And also FCD. Again, it's a two-force member. I know the line of action. The only unknown is the magnitude of the force. Okay. So I'm going to take then and draw a free body diagram of BDE. So this is what I have. Okay, here's my axes again. Y and X. Here's BY. Again, I'm assuming directions here. Doesn't matter. There's BX and BY. All right, I have FCD. Okay, and then I have EY. Again, be consistent. All right, on my free body diagram of the entire frame, I have EY vertically upward. I solve for EY as 3. So I'm going to make sure I put EY when I take the frame apart. On this member, I'm going to have EY vertically upward, just like I have on the complete frame free body diagram. And then I've got the 4 kilonewton load that's acting like this, okay, horizontally to the right. Okay, so I look at this and I say, all right, sigma fx is equal to 0. It says bx plus 4 is equal to 0. So bx is equal to minus 4 kilonewtons. Okay. Again, the negative sign simply means it's actually going in the other direction. So if you assume that bx was going this way, then you get a positive 4 for this answer. Okay. My y equation, I have 2 unknowns in the y equation, by and fcd. I know what ey is. So rather than write that equation, I say, well, if I sum the moments around b, I can get fcd. If I sum the moments around d, I can get vy. Okay. And then use the y equation to get the other one. All right. So I sum the moments around B like this. Yeah. Okay. So I have a moment caused by FCD. It's positive because I'm assuming clock or counterclockwise is positive. It's FCD. If you look at the the diagram, the moment arm is 100. Okay. So there's the moment caused by FCD. I have a moment counterclockwise caused by EY. All right, and its moment arm is 200. Again, looking at the diagram. Then I have a moment caused by this 4 kilonewton force here. Again, it's going to be counterclockwise, so it's plus 4. And its moment arm is 200 equals 0. Okay. Again, just coming up here. The moment caused by F, all right, about B is F times its moment arm, which is 200. EY, its moment arm is 200 as well. Okay. All right. So solving this, I get FCD is minus 14 kilonewtons. Okay. Again, it's actually going in the other direction, but you never go back and change your free body diagram. And then finally, sigma Fy is equal to 0, tells me By plus FCD plus EY is equal to 0. All right, so this is By minus 14 plus 3, because EY is 3, equals 0. So By then is 11 kilonewtons. Okay, is that problem solved? Again, if you reverse the directions on your free body diagram, in other words, if I had By, if I assume By is going vertically downward instead of vertically upward, then the magnitude is still 11 kilonewtons, but it would be negative. Okay. All right. So that solves problem number 6.